Today we take a deeper look at the functional area control and monitor. The question here is how to control the charging process optimally and reliably. The functional area control and monitor represents the intelligence behind the charging station. It is securely supplied by the functional area power reliability. It collects and processes information in order to control the charging process. Data is also exchanged via the functional area network and communicate. And, of course, it needs electrical connection technology. Despite identical functional requirements, AC and DC applications differ in the selected components. Let's start with AC charging. The controller handles communication for charging the vehicles and is seen as the central communication node, the heart and brain of the charging station. This is where charging processes are released, started, controlled and stopped in connection with the vehicles via pulse width modulation, PWM for short. The PWM signal indicates the maximum accessible charging current to the vehicles. The controller can fulfill other functions in this context, which contribute optimal regulation of the process. These include, in particular, load management for charging parks. In this picture, the available connected load is distributed equally to all charging points. This protects the grid connection against overload and the distribution grid against unbalanced loads. Instead of an equal distribution, certain charging points can be prioritized higher or lower, as shown here. This can be useful for short stay or VIP guests, for example. The coupling between buildings, charging infrastructure operators, energy generators and grids, charging stations and vehicles is becoming more and more important. This sector coupling is required for optimal energy usage and carbon-neutral mobility in the all-electric society. It requires different communication protocols which must be supported by the charging controller. CHARX Control Modular fulfills all of these requirements. The controllers are available in different variants, so they can be tailored exactly to the target application. The 1000 class with a narrow housing provides all interfaces and functions necessary for a standards-compliant charging process. The 3000 class includes all of the function of the 1000 class, but comes with additional intelligence and full connectivity. While the 1000 class is only available in one variant, the 3000 class is available in 4 variants with respect to mobile communication and ISO 15118. The 1000 class can be used as a standalone controller for single charging points without a network connection. The 3000 class adds network connection and support for commonly used protocols. By combining 1000 and 3000 class controllers, an expansion to up to 12 intelligent charging points is possible. In total, up to 4 of these blocks can be connected via Ethernet, so that up to 48 charging points can be integrated into one management system. Optionally, an AC energy measurement can be connected to the charging controller. This is required if energy costs are to be billed or load management is to be implemented. An energy measurement is always recommended as a source of information in order to optimize consumption. In addition, the energy values can be used for safety measures. For example, the controller can shut down the charging process in case of an overcurrent. Our eMPRO energy meters are MID conforming, meaning that they fulfill the European Measuring Instruments Directive for billing processes. They are typically connected to the controller via RS485 and also offer web-based data management via Ethernet. The CHARX controllers and eMPRO energy meters are pre-configured, so they work together perfectly and are ready to use very quickly. A residual current measurement is a safety feature which is required by law in AC charging stations in many countries. It detects AC and DC currents which do not flow from the car back into the grid, for example due to faulty insulation. The measurement can be done using a Type B circuit breaker which detects both AC and DC residual currents. A much less expensive alternative is a Type A circuit breaker. Since it detects only AC residual currents, it must be combined with a DC residual current measurement. Type A and Type B circuit breakers are available on the market. A suitable DC residual current monitoring module is available as an accessory for CHARX control modular. It is connected directly to the controller and can be configured there. For measurement, the lines of the charging cable are guided through the toroidal coil of the module. The cabling does not have to be integrated into the device, making the safety feature easy to implement. A temperature measurement on the power contacts is not required for AC charging. However, it can be useful in order to early detect overheating in the charging process for more safety. Overheating can be caused, for example, by increased ambient temperatures, intense sunlight, or high utilization of the charging station. A temperature measurement is already integrated into the premium version of the charging socket's CHARX Connect, a space-saving feature which requires no additional installation work. Alternatively, the measurement can also be done using separately connected temperature sensors. Now let's have a look on DC charging. In general, the DC controller performs the same functions as the AC controller, but instead it is designed for DC currents. Our DC controller, CHARX Control Professional, offers the option of operating two independent charging points, AC and DC. It allows for flexible fast charging using CCS and CHAdeMO connectors in accordance with the specified IEC standards. During DC charging, the controller actively communicates with the power electronics, which is described more detailed in the functional area Charge. First of all, the controller specifies important charging parameters such as current and voltage. Secondly, it receives temperature or fault notifications from the power electronics in order to adjust the charging process accordingly. For load management and billing, a variety of information is required. Theoretically, an AC side energy measurement would be possible here. However, due to the power losses in the AC-DC conversion, the billing would be based on incorrect DC values. Therefore, regional standards and laws often require one DC side energy meter per charging point in order to ensure a precise measurement. Typically, DC energy meters are available on the market in two power classes, up to 100 and up to 500 kilowatts. The residual current measurement detects DC fault currents in order to be able to securely interrupt the current feed in the event of an error. This is also a safety feature in DC charging stations and is required by law in many countries. Appropriate devices are available on the market. In contrast to AC charging, a temperature measurement on the power contacts is required by applicable standards in order to have the greatest possible safety, even at high power levels. Because of this, PT1000 temperature sensors are integrated into our DC charging cables CHARX Connect. This ensures that the temperature development is monitored throughout the entire path to the vehicle. Depending on the equipment of the charging station, the charging process can be interrupted or the charging cable can be cooled as needed. Overall, Phoenix Contact offers almost all components for optimally controlling and monitoring AC and DC charging.